Hi, my name is David Buchanan. I'll be one of the presenters for Team Eastern Centrals for our project on a fire drug interaction checker. Our team members are Abhinav Gagna, Ejike Ude, Alex Dykstra, and Harem Davis. Our mentor is Dr. Fred Abidi from Logicoi, and our TA mentor is Taylor Starton. So drug interactions have become a serious issue with the amount of drugs on average that people are taking. According to the CDC, the percentage of Americans taking more than 5 prescription drugs has nearly tripled in the past 20 years. The problem with taking multiple drugs is that it increases the risk of adverse drug interactions. Michael Hockman of the USC's Keck School of Medicine states, the risk of adverse events increases exponentially after someone is on 4 or more medications. So this shows a need in a market for drug interaction applications. The issue with most current drug interaction apps is that they require the user to manually enter in every drug they wish to check for interactions, which can be slow and a tedious process. So our app provides a more convenient solution by leveraging a user's electronic health record to retrieve the prescribed drugs they currently take. And a user can also enter any over-the-counter drugs they currently use. And then a combination of these two lists are checked for interactions, resulting in a faster and more convenient interaction checking experience. So the goals of our project were to create a Smart on Fire application that integrated with a Fire-enabled electronic health record API. And from that EHR, retrieve a patient's prescribed drugs and check for interactions. We also wanted to include the option of allowing a patient to enter any over-the-counter drugs they currently use and check for interactions for those. To help with organization of the interaction alerts, we wanted to also include a interaction severity feature. This goes along with developing a simple and user-friendly interface. And lastly, we wanted a successful deployment to Georgia Tech's Health Data Analytics platform.
We created a web application with the front end programmed in Angular 6, which is a combination of TypeScript, CSS, and HTML. For the back end, we used the Spring MVC, which is written in Java. During development, we used a combination of IntelliJ, Docker, and Maven. Inside of Maven, we used a plugin which enabled us to build our front end, which is written in Angular, which uses the Angular command line interface to build and deploy a front end application into a WAR file, which was then used inside of Docker in a Tomcat instance while running the backend from the same Tomcat server. During development, we also used Photoshop and Lucidchart in order to create our architecture diagrams. And inside of the application, we used the drug interaction API, drug bank API, and ONC High API for our actual tool development.
My name is Hiram Davis. I am a back-end developer on the project. I'm going to give a demonstration of looking up drug interactions using our application. When you first access the application, you are presented with the list of patients. These are loaded in dynamically via the Fire API doing a patient search. For this demo, I'm going to pick Benja Hamlinson. After you pick a patient, our application will call the Fire API and obtain a list of medications associated with the patient. The medications we found are displayed review on this page. The next step allows the patient to add any other medications they may be taking, including over-the-counter medication. The user can enter a drug or a brand name here that includes a partial name, and our system will search the NLM API for the drug. Results are displayed in list form, allowing the user to pick the correct choice or search again. For this demo, I'm going to enter 2 drugs I know will result in a severe interaction and 1 over-the-counter medication. When the user's done entering all of their drugs, they click Next. The list of drugs that we loaded in earlier is again displayed in addition to the drugs that were entered on the previous page. When the user clicks Finish, our application will contact the NLM Drug Interaction API with the list of all medications entered, calling this twice to get both the severity data from the ONC High database and description data from the Drug Bank database. The final result page displays the interactions we found from the API. For the submitted medications, 2 severe interactions were identified. They are highlighted in red and contain the description information provided from the API. We also added a convenient way for patients to learn more about the medications they are taking. Clicking on prescriptions or over-the-counter options will open a list of the medications that were entered earlier. Each medication links to the drug bank entry for that medication. From here, the patient can view more in-depth information about the medication.
Hello, I'm Abhinav. I will discuss successes we were able to achieve for Drug Interaction Checker. Drug Interaction Checker is a simple-to-use, intuitive application that any patient can easily use. For the application to work, we were able to seamlessly integrate multiple APIs from various sources and provide the drug interaction results. One of the biggest achievements is to separate the back end, the brains of the operation, with the front end as 2 distinct entities. The back end can be plugged in and used separately if needed. The external APIs that we incorporated with are mostly from National Institute of Health and National Library of Medicine. Both are federal entities that provide reliable data. The successes of project include ability to pull patient medication records to check for interactions. This feature simplifies patients' ability to just enter a drug name, and the interaction checker will compare that with all the prescription drug he or she is on. NIH Drug Interaction API checks for drug interaction and provides us the interaction results along with the severity of the interaction. Over-the-counter service API lets you enter name or brand of the drug and let users select from the results. One of the major successes was the UI design. An application is useless if the UI design is not intuitive. We worked very hard to make our application look beautiful and simple for patients to use it. We were able to integrate a lot of technologies and frameworks such as Spring, Angular, Docker, Jenkins, etc., and automated build deployments to HDAP. Future opportunities. Although we accomplished a lot in relatively short time frame, we think that this project can easily be enhanced further. Integration with Epic Orchard can be productionalized. Our application worked with OAuth simulator on the Epic, but to put it in production is a longer process. This will enable the OAuth to deploy in any environment and will enable patient EHR login through our application. There's a possibility of enhancing this app to make it provider-facing, especially since the backend is a microservice. A mobile version of the application can be developed with additional functionalities.
Hi, I'm EGK and I'll be walking you through our project timeline. We started off the project with a requirements gathering phase where we met with our mentor, Dr. Abidi, to discuss the drug interaction problem space and how we can help provide a solution that meets his needs and expectations. Following this, we defined our project scope, selected a suitable technology stack, and designed the system architecture for the application. We then began full software development and testing and had weekly check-ins with our mentor for feedback and to ensure that we stayed on track. In the course of the project, we experienced a number of challenges, including losing a team member and some issues with our HDAP deployment, but we were able to resolve these issues without any major impediments. Regarding our current project status, we successfully concluded application development and testing of the Drug Interaction Checker app, and were able to demonstrate the final version of the application to our mentor, who was satisfied. The application has since been deployed to the HDAP server and also added to the Georgia Tech HDAP gallery.